The last couple of days, we proved triangles or other figures congruent. And in order to do that, what did we have to prove was congruent? If I had two triangles and I said, let's prove that these two triangles were congruent, what did we have to do yesterday?
The side and angles are the same?
Yep. And so I would end up having 6 pieces, right? And I had to have 3 sides and 3 pairs of angles that are all congruent. That's a lot of stuff, right? Six pieces was a lot of stuff to prove. Well, the good thing is going forward, we won't have to have that many things. Going forward, we can have 3 pieces, but it has to be the right 3 pieces, and then I can prove that the triangles are congruent. So today we're going to talk about one theorem for triangles, and this only works for triangles. This doesn't work for other figures, but we call it the side angle side congruence theorem. And we're going to abbreviate it SAS for short. So in order for 2 triangles to be congruent, rather than proving all 6 pieces congruent, if I have one pair of sides and an included angle and then another pair of sides, so the angle has to be between the 2 sides that we know are congruent. If that's the case, then we have side angle side, okay? And it just kind of follows the path, side, angle, side, in that order. And it doesn't really matter which side I would start with. I could start here and say side, angle, side, as long as it's the angle in between. If it was angle E or angle F over here, then it wouldn't be between it, right? And so then that wouldn't work. So it has to be specific pieces. But as long as both triangles have 2 sides congruent with an angle in between those 2 sides congruent, we have congruent triangles. And we don't have to prove the other 6 pieces, okay? So what we're going to do is we're going to do some proofs of these. And we're going to prove side angle side congruency based on what we now know, that we can use side angle side. And you can kind of do it however you want. I sometimes like to redraw the 2 triangles separately. Just so we can mark the pieces of it, okay? And most of the time, we're going to write this as a 2-column proof because that's probably going to be the easier way to write it. Sometimes I'll show you we could just write a statement out, but if it says write a proof, then we typically are going to do that as a 2-column proof. This triangle here is ABC. This triangle down here is ADC. And we know that our first step on our proof is always our given, right? And sometimes they tell us what that given information is. Yesterday we saw some problems where it's just marked on the picture, okay? And so either one of those or both are okay. In this case, we're going to list those 2 pieces of information out. BC is congruent to DA. BC is parallel to AD. Okay, so right now, if we were going to do side angle side, I have one side. I need 2 more pieces to do side angle side. Okay, so let's start with sides first. As I look at these 2 triangles, is there another pair of sides that I could prove congruent? Okay, CA, right? And there's a lot of different ways that you could write that. Up here I'll write given, because that's our given information. I could say CA is congruent to CA, or I could say CA is congruent to AC, however you write it. Really doesn't matter if you call it CA or AC. That means the same thing, okay? And how do we know that these 2 sides are congruent? Reflexive property, okay? It doesn't matter if I flip the letters like I did here. Is CA and AC still the same thing? Yeah, it's still the same thing, right? So don't get confused by, sometimes you'll see that, and I want you to see that here as well, that I can say AC is congruent to AC, and that would make it more easier to recognize. But CA and AC are the same thing, okay? Those two sides are congruent because they're the exact same side. And so that is the reflexive property. Okay, so now we have two sides. I need the angle in between those two sides. So if I go back up here to this picture, if these are the two sides, I need this angle and this angle to be congruent, if these are going to be congruent triangles, okay? What do we notice about these two sides? Well, they told us that they were parallel, right? So if those two sides are parallel, what kind of angle relationship would these two angles have?
Alternate interior.
Alternate interior, okay? And what do I know about alternate interior angles?
They're congruent.
They're congruent, okay? I can say that this angle and this angle are congruent. And be careful when you name it, because I have to use 3 letters when I name those. Angle BCA is congruent to angle DAC. And I would just say something like, if we have parallel lines, which we do, then alternate interior angles are congruent. I'm totally okay with abbreviations, but I don't just want to say alternate interior angles, because I could have alternate interior angles, like I could draw up a picture right here. These two angles here, 1 and 2, are alternate interior angles, but they're not congruent because these two lines are not parallel, okay? So we can't just say alternate interior angles, because alternate interior angles aren't always congruent. So what we must say is that we know we have parallel lines, so therefore the alternate interior angles are congruent, okay? And so then I know that this angle and this angle are congruent. And so now my final statement is going to state that these two triangles are congruent. Triangle ABC is congruent to triangle CDA. By side angle side. A much easier proof than yesterday, because we don't have to name all 6 pieces. And so it's a lot easier to get to congruency here. Okay, so that's a side angle side proof. Bless you. On this one here, there's all kinds of triangles in this picture, right? And so make sure that you're focusing on the 2 that we are dealing with here. Okay, the 2 that we are dealing with is SVR and UVR. I'm going to outline them here. Thanks. These are the 2 triangles that we are focused on. And I'm just going to redraw them, okay? Because in a picture like this, we have all kinds of triangles that we could be working with. Okay, it tells us that ABCD is a square. It tells us RSTU are midpoints of AB and CD. Also, RT is perpendicular to SU. SV is parallel is congruent to BU. All kinds of information is given there. Okay. If we were to do this as a 2-step proof, I would start with SV is congruent to VU. It's not already marked on the picture, so now the new one that I drew here, I'm going to go ahead and mark it. We're trying to prove that these 2 triangles are congruent, so right now I have one side. Okay, another piece of information that is big here is RT is perpendicular to SU. And I guess I don't really need to write step 2 there because we'll include that in step 1 as part of my given, because that was given information. So all of that will be step 1. Okay, so if RT is perpendicular to SU, what's that tell me about these angles right here? They're 90 degrees, okay? So I'm going to say angle RVS and angle RVU are 90 degrees. Okay? How do we know that? What would be our reasoning? How do we know they're 90 degrees? Okay? And so what would we say for our reasoning? Remember, our reasoning is going to be a property, a postulate, a theorem, a definition. So what do we, if I was to ask you, define perpendicular, what would you say? What'd you say, Adrian? They intersect, and where do they make when they intersect? 90 degree angle, okay? So we know what perpendicular means, right? That is the definition of perpendicular. Okay. That's how we know they're 90 degrees, because we know what it means to be perpendicular. We know the definition of that. So we're going to go ahead and mark those as 90 degrees. Okay? What else? Right now we have two sides that are congruent. We have two angles that are congruent. They're both 90 degrees.
RV and RV are congruent because of the reflexive.
Perfect. Okay? And one thing that you're going to start to find out is we're going to use that reflexive property a ton on these proofs. If they have a shared side, it's almost like a given statement because we want to use that. But we still have to say something about it because it hasn't been stated that they're congruent yet. So it's kind of like a given statement because if they share that side, we know they're the same, but we want to state that as being congruent. Okay? Do we have enough? Yeah. Okay. So our final statement, and you don't have to come up with your own statement here, as if it's stated right here, we're trying to prove that those two triangles are congruent. So just copy that down here into step 4. Triangle SVR is congruent to triangle UVR because of side angle side. Right now, the only way that we can prove triangles congruent, other than all 6 pieces, is side angle side. Next week, we'll get into some other ones where we can do some other parts. But today, it's only side angle side. So it has to be 2 sides with an angle in between them. Okay? This one here. We're talking about this, we're making a sign for this building here. We have 2 identical triangle sheets of canvas. And so I'm going to redraw. You can separate them if you want to. I'm just going to redraw the triangles here. Okay, given information. We know that PQ and PS are congruent. We also know that RP is perpendicular to QS. So this is going to be very, very similar to the one we just did. order doesn't necessarily matter, but I can say that R, P, Q, and angle SPR equal 90 degrees. And once again, the definition of perpendicular. See ya. Okay, what else do we know? What other side would we need here? I've got a side, an angle. I need this side right here. Okay, what do we know about this side? It's a shared side again, right? Those two triangles, the triangle over here and the triangle over here, share side PR. What if I call it PR and somebody else calls it RP? Same thing, right? Order does not matter here. So I could say PR is congruent to PR because of the reflexive property. Okay, and then so to finish this one up, we're going to say triangle PQR is congruent to triangle PSR by side angle side. Very, very similar to that last proof that we did. All right, this last one here, we've got this window here. We want to make DRA congruent to DRG, the two triangles. So I'm going to redraw that. And we want DRA to be congruent to DRG. You can do a two-column proof, but what I would also say here is if it doesn't say write a formal proof, you could write it out as some statements, and I'll kind of show you what that would look like here. And I'll kind of give you guidance on like when you should or when you shouldn't do a proof. But in some cases, you wouldn't necessarily have to write a two-column proof. I know that's the way we're going to see it most of the time. But on this one, we could say that DR is congruent to DR by the reflexive property. DA is congruent to DG, and angle ADR is congruent to angle GDR by the given information. So we know this angle and this angle are congruent. We know these two sides are congruent. They are shared by the reflexive property. Therefore, triangle DRA is congruent to triangle DRG by side angle side. Okay. So pretty similar to writing a two-column proof, but you could just write the statements out and use it as well. Just got to have enough information to prove that the triangles are congruent. Okay.